Hello and welcome back. In this video we'll discuss systems of linear equations in two variables. A couple of vocabulary words here. We got system of linear equations. It's simply a set of linear equations, meaning two or sometimes two or more, with the same variables. It's called a system of linear equations, or sometimes called a linear system. So they have to have exactly the same variables. The solution of a system is the ordered pair. This is an ordered pair. That is a solution of both equations at the same time. There are three basic methods of solving systems. The first method is graphing. And you can see we have two graphs on here in two different equations. And the location right here where the two equations cross is the solution. And the point right there is actually 3, -1. So if I take 3 and put it in for x here, put the -1 in for y here, you'll see that that does come out to a 9. And the same thing over here, if I put a 3 here and a -1 here in place of y, that will also come out to a +5. And that's what makes that the solution. So we got to find that one particular point where the two lines would intersect. Now, intersecting lines have one solution. So two lines that intersect only intersect in one place. We sometimes refer to this as a consistent system. If we have two lines that are parallel, that means they have the same rise and run, but they have different y-intercepts. Then these two lines will never have a point in common at the same time, which means they have no solution. So parallel lines have no solution, and we sometimes refer to this as an inconsistent system. The last one is coinciding lines. You might be able to tell here there's a blue line in the background and there's a dotted red line on top of it. That's because these two lines are exactly the same. What that means is every solution in one equation is also a solution in the other equation. So they have infinite number of solutions. And another name for coinciding lines or infinite solutions is also referred to as a dependent system. The graphing method is not typically the most efficient. There are two other methods we're going to look at. There's actually a fourth method which we may cover later in the year. And one of the two methods is called substitution. The other one is called linear combination. Both of these attempt to remove one of the variables from the problem. When you remove one of the variables, you end up with a one variable problem left over, or a multi-step equation involving only one variable. Example 1, we want to solve these systems, and we're going to use the substitution method. Now, the substitution method works best when you have one variable already isolated, or you have one variable that has a coefficient of 1. That x has a coefficient of 1. So what I'm going to do is rewrite that as x is equal to 5 plus 2y. Now, since both of these equations have x and y equally, both x, both y, I'm going to take this value, which is actually x, this entire expression, and substitute it right here in place of x. So I'm going to rewrite that as 4 times, and in parentheses, 5 plus 2y. Remember, that was x, but now we'll replace it with what x is equal to on this side, plus 3y equals 9. And now you can see I have a multi-step equation that has only one variable left in it. Now we just continue to solve until we get y by itself. So we're going to distribute. We get 20 plus 8y plus 3y equals 9. Combine like terms, so we end up with 20 plus 11y is equal to 9. Subtract 20 on both sides, so 11y is equal to -11. Divide both sides by 11, and we get y is equal to -1. So the solution to a system is an ordered pair. So I'm going to start my ordered pair, and I know that my y value is going to be -1, so part of my solution is -1. So how do I find the other part of my solution, which is x? Well, let's go back to this equation here and replace y with -1, because that's what we got up here for the solution, equals 5. So x and then -2 times -1 is +2 is equal to 5. X then would equal 3. So the point on the graph where this line and this line intersect, that's known as the solution, they will intersect at the point 3, -1, which happens to be the solution for the system. That's called the substitution method. Example 2, you'll see we have exactly the same system of equations. However, we're going to use the linear combination method. That means we're going to make the variables cancel out by adding or subtracting the equations together. Well, in order for the variables to cancel out, one or the other, but not both, we have to make sure the coefficients are the same. Well, let's look at the x's. Those are the easiest ones. So since this one has a 1 on it, I can make it look like a 4 simply by multiplying this entire equation over here by 4. So 4 times x is going to give me 4x, 4 times 2y is going to give me negative 8y, and 4 times 5 is going to give me 20. So all I've really done is transform this equation to look like that one. It's still equivalent because all I did was use the multiplication property of quality. So here's where the combination technique comes into play. I'm going to take that equation and place it over here underneath that one. I'm going to go ahead and draw a line and put parentheses around the second one. And what we're going to do is either add or subtract our equation here to make the x's cancel out. Well, I've got a 4x on the top and a 4x on the bottom, and the only way you can get them to become a 0x is to subtract. So 4x minus 4x gives you 0x, and 3y minus negative 8y will give us a positive 11y, and 9 minus the 20 will equal negative 11. Well, 0x just drops out of the problem. There's no more x's in the problem. All I got to do now is divide both sides by 11, and y will still equal negative 1. Well, if negative 1 is my y value, I can solve for my x value by taking that negative 1 again and putting it in place of y and solving for 5. So I have x plus 2 is equal to 5, and x is going to equal 3. So we see that our solution is still 3, negative 1, like it was on the previous problem, only using the linear combination method. Example 3, two new systems, two new equations, and we want to know which method should we use. Well, you can use either method you want, but sometimes one method is easier than the other. Well, since the coefficients are not set to 1 on either of the equations, the best thing to do is use the linear combination here. So what I'm going to do is look at the x's and look at the y's and decide which ones are easier to make identical. Well, I think that making the y's become the same would be the easiest way to go. So I'm going to multiply this equation by 10, and I'm going to multiply this equation by 4 so that my y's will both become 40. So I get 30x minus 40y equals 140. And over here I get 16x plus 40y is equal to 44. Now I got to make sure that these two line up, so I'm going to rewrite them so that they line up underneath each other like this, where the x's are lined up and the y's are lined up. Draw my line, put parentheses around the bottom. Now my y values are the ones that have the common coefficients, so I want to make them cancel out. One's positive, one negative, so all I got to do is add them together. And what I end up getting is 46x plus 0y is equal to 184. And what you'll notice here is that 0y is going to drop out of the problem because it's just 0, so all I have left over is 46x equals 184. Divide both sides by 46 and x will equal 4. So part of my solution is a 4 for x, and then I got to find the coordinate of y. So go back to the original equation. Don't go back to the altered equation. So ignore these when you go to solve for y. Let's look back at the original equations. Let's say I look back at this one right here, and in place of x I'm going to put 4 because that's what x was, plus 10y is equal to 11. Now I get 16 plus 10y is equal to 11. 10y then is going to equal 11 minus 16, which is going to give us a negative 5. And divide by 10 on both sides, and y is going to equal negative 1/2. So our solution will be 4 comma negative 1/2, and that's where the two lines will cross each other on the graph, creating the solution to the system. Example 4, which method would we use? Well, we can see that we have a coefficient of 1 on this side, but we already have y isolated on that side. When y is already isolated or x is already isolated, that's usually a key indicator that you should probably try substitution method. So I'm going to substitute this entire expression in place of y, but I'm going to substitute it in the other equation. You can't substitute it into itself. So we bring down our x plus 2, and then anytime we go to substitute, we put parentheses, and we're going to substitute the negative 1/2 x plus 4, and the whole thing is still equal to 11, or to 1. Distribute, so the x plus 2 times negative a half is negative 1, and then the 2 times the 4 is going to give you 8. Combine your like terms, so x plus 7 is going to equal 1. X then will equal negative 6 when you subtract 7 from both sides. But that's only half of our solution. We have an x of negative 6. We got to go back and calculate the other half, which is the y value. Since y is already isolated on this equation, we should take this negative 6 and substitute it right there. So y is going to equal negative 1/2 times, this is negative 6 over 1, plus 4. Well, negative times a negative is going to be a positive. 6 over 2 is going to give you a 3 plus 4, and y ends up equaling 7. So the solution to this system would be negative 6 comma 7.